Hello everybody, this is an intro to natural logs presentation. These notes are coming from the shared drive on Google Classroom. All right, so you can print them out and fill them in, or if you want, you can just start writing things down on your own piece of paper. But I wanted to kind of give you an intro to natural logs today. First off, what is E? E is an irrational number with an approximate value of 2.71828 ... So E is an actual number that shows up in nature. That's part of why it's part of the natural logs, and it has a value. So being an irrational number, it doesn't repeat decimals and it does not terminate. E often occurs as the base of exponential and logarithmic functions that describe real-world scenarios. Base E exponential functions. Exponential functions with base E called natural base exponential functions. There's that natural number coming again, the natural word. Okay, so base E, I want you guys to automatically associate E with natural or nature. An example of this is f of x equals e to the x. E to the x is an exponential function. Base E exponential function has that form. Base E logarithmic functions are called natural logarithms or natural logs. So logarithm functions with the base E can look like this. F of x equals log of E of x and are often abbreviated as ln of x. I know you probably should think, I always used to think that it should be NL, not LN, so that makes it a little bit different. But that is the natural log of x. All right. One of the main ideas that I want you guys to walk away with from today is being able to convert between forms. I want you to be able to convert from an exponent to a logarithm form, and then from the logarithm form to exponential form. So number one, we have e to the x equals 24. Remember that we can always express exponents as logs. Our base is e, so it would be log base e of 24 equals x. So far, nothing has changed. We're not changing anything from how we express exponentials to logarithms. To convert a log base e of 24 to express that as a natural log, you just replace the log base e with ln. Easy peasy. Number two, we have e to the 9th equals x. To rewrite this as a log base e, we have log base e of x equals 9. To represent this as a natural log, you replace log base e with ln. And then number three, this one's a little bit more challenging. We have e to the x plus 5 equals 72. Same thing. The form and the pattern do not change. Just because we have x plus 5 in our exponent, that doesn't mean anything. That just means it's a little bit more explicit. Okay, so we have log base e of 72 equals x plus 5. And again, to express this as a natural log, you replace the log base e with ln. All right, now we're going to rewrite our logs as exponents. So we have the natural log of x equals 58. To rewrite this, I kind of like to go in order. If you see on the very bottom of the page here with our little remember, from the natural log ln of x to the log base e of x to e to the x. By doing that, I add this little e in between natural log and x. That kind of tells me that all I have to do is express it as my base of e to the 58th equals x. So number 5, I have the natural log of 6 equals x. To rewrite this as an exponent, I toss in my base e to the x equals 6. And then number 6, again, this one's a little bit more complicated, I guess, because we have the parentheses here. But again, our order does not change. So I go ahead, toss in that base of e. To express this as an exponent, I have e to the 32nd equals x minus 9. For the next section here, we are going to be rewriting natural logs using properties. So we're going to condense and we're going to expand. So I just wanted to briefly review the properties of logarithms because they are the same when it comes to natural logs. So we have the product rule. When we multiply logs, we end up adding them together. Whenever there's a quotient rule, when we divide log base b of m divided by n, we can split that up. We can expand it to be log base b of m minus log base b of n. And then the power rule, we have log base b of m to the n. All we do is we bring that n out in front of our log and we multiply it by the whole thing. Okay, so I really want you guys to be very familiar with these rules. This is really going to help us out. All right, simplifying with the properties. Condense each expression into a single logarithm. Number 7, we have the natural log of 3 plus the natural log of 16. This tells me that I'm going to be using the product rule. To use the product rule, I have to multiply 3 and 16. 3 times 16 is 48. So my answer is the natural log of 48. Pretty easy. Do have to say, we have to make sure that our bases are the same. Natural logs have a base of e, so they are all good to go. Number 8, we have the natural log of 63 minus 2 times the natural log of 3. What I like to do first is work with the 2 times the natural log of 3. That is the power rule. What that means is we toss this 2 as our exponent attached to the 3. We know what 3 squared is. It's 9. We also know that this minus tells me that I'm going to have to divide 63 by 3 squared, or by 9. So 63 divided by 9, that can be simplified into the natural log of 7. Number 9, we have 2 exponents we have to deal with, and we're adding. So that tells me that I'm going to be using the power rule, and I'm also going to be using the product rule. Before I use the product rule, I have to use the power rule. What this 1/3 means is I am going to put 64 to the 1/3 power. Now, if we recall from radicals, that means that 64 to the 1/3 power is the cube root of 64. And this 2 is just going to make this x squared. So in this next step here, I have gone and I've expressed, or I've condensed out my my power rule. Now I can do some math here. If you have your calculator with you, or if you need to go on desmos.com/scientific, I highly suggest that you do that right now to calculate and see if 64 is a perfect cube. And it is. The cube root of 64 is 4, plus that means we're going to be using the product rule. So we're going to multiply 4 times x squared to get the natural log of 4 times x squared. Again, I got 4 from the cube root of 64. If you can do your simple math, you do it. Okay, there's nothing different with that. We're just simplifying. All right, last but not least, simplifying by expanding each logarithm. For number 10, we have the natural log of 5 times x. This means that we're going to be using the product rule. To expand a product, we add the natural log of 5 plus the natural log of x. We have expanded this logarithm as much as we can right here. Number 10, we have the natural log of a cubed divided by b, all to the second power. Now, before I expand anything by using the power rule, I'm just going to deal with this too. I'm just going to deal with this squared because that's a whole lot of fractions and that's really not simplifying it, okay? So we just have to use our exponent rules first for the exponent rules of just regular old math that we went over at the very beginning of this unit. Then we're going to expand it. Okay, so first things first, when I have a power to a power, that means I multiply my powers. So I multiply a cubed times 2. 3 times 2 is 6. Then I can't forget about this denominator. So b also has to be squared. To rewrite this, I have the natural log of a to the 6 divided by b squared. Now this is just a division problem. So what I do to expand this natural log is natural log of a to the 6th minus natural log of b squared. And last but not least, we have this cube root. I apologize. The natural log of the cube root of m squared times n. So we can't simplify anything, right? We can't pop anything out because we have a cube root and this is squared and this is n to the first power. So we can't simplify anything just by using our radical powers. What we can do is rewrite this as an exponent though. The cube root of m squared basically means that we're going to multiply 2 times 1/3 because anything raised to the 1/3 power is a cube root. We can't forget about raising n to the 1/3 power as well. So what I did here is we have the natural log of m to the 2/3. 2 times 1/3 is 2/3. N to the 1/3 stays that. Now we have exponents and we also have multiplication. So that means that we're going to have to use the power rule and the product rule. So to split things up, I have the natural log of m times 2/3 plus, because this whole thing is a product, plus 1/3 times the natural log of n. Alrighty, I hope that this was helpful to you guys. I want you to get some more practice. Good luck out there.